Good afternoon, everyone. Am I loud enough to keep you all awake after all the food? Amazing, amazing. So welcome to today's fireside chat on The Future is Open, where we are going to discuss Google Cloud's open data ecosystem. That being said, let me introduce myself, right? So I'm Mansi Maharana. I am a data and analytics specialist customer engineer at Google Cloud, where I work for the select financial services accounts. I've been with Google Cloud for about 2 years now, where I primarily focus on bringing in my thought leadership in data governance space and my technical expertise in data and AI ML. And I help my customers go manage, optimize their data, maximize the value, both in a hybrid and a multi-cloud environment. So prior to Google, I worked for Cloudera. And thanks to my days at Cloudera, if there are any Clouderans here, I see a couple. Thanks. So thanks to those days, I have acquired this technical expertise and skill set on architecting large-scale mission-critical applications, all based on open source technologies such as Hadoop and Spark. So that being said, today I have with me a technology expert, a data enthusiast, my favorite peer to go for any data questions, Anagha. Please take a couple of minutes to introduce yourself.
Sure. Hi, everyone. And first off, this was supposed to be a fireside chat. We're going to be sitting on chairs, very comfortable, imagining a fireplace and chatting, but we've got this setup. So our setup is going to be different. We are going to have very few slides and a lot of talking, and it's going to be more of a fire hose. So if you're data engineers, if you're cloud architects, expect a lot of information. So let me start by introducing myself. I'm Anagha Khanolkar. I'm based out of the Chicago area. I'm a customer engineer at Google Cloud. I've been at Google for about 1.5 years, and in my current role, I help enterprises solve business problems with Google Cloud solutions, especially in the analytics space. And they're invariably big data and often OSS-centric. Prior to Google, I worked at Azure at Microsoft as a principal solution architect, doing the exact same thing, working with customers with scale issues, architecting big data solutions. And before Azure, I actually was a career data engineer and big data architect, building massively scalable pipelines on AWS and on-premise Hadoop ecosystem technologies. And I have a career spanning about 22 years building, architecting data-intensive applications. I'm passionate about open source, big data, and cloud computing, and I'm very happy to be here today and to share with you Google Cloud's open data analytics portfolio. Back to you, Mansi.
Thank you, Anagha. So you can see we are all very techie people. So if you have any questions, feel free to talk to us after this session. But before we begin, a few housekeeping items and the scope for this session. Right? So first, today's session is 35 minutes long. So we are going to use the first 30 minutes to just go over the fireside chat part, and then last 5 minutes dedicated for Q&A. We don't know if we can keep it on time. We'll try our best, but we'll be available to talk and chat after we are done. 3 takeaway items from this session for all of you. Right? First, you will learn how Google has and continues to inspire the open data analytics ecosystem with a wide, diverse range of data and analytics products, which is built for every persona. Second, you're going to learn how OSS has intelligence built in and is designed to improve engineering productivity and also the speed to market. Third, you're going to learn the top data and analytic products on Google Cloud with open source at its core. Plus, we are also going to discuss a strategic partnership with the OSS open source businesses such as Databricks. So that being said, let's begin. Right? So my first question to you, Anagha, could you please explain why open source is significant and what is the current trend with it?
Sure. So this is a research. What you see on the slide here is research done by Boston Consulting Group, published last year. And what they found is 99% of Fortune 500 companies use open source technologies. 80% IT departments plan to increase their open source footprint, and 35% of all enterprise software is open source. This is very much aligned with what Google is thinking in terms of innovating and contributing to open source. And at the heart of Google, we love open source, and we believe that open source solves real-world problems for everyone. We are constantly innovating, contributing back to the community, and today we have 2,000 open source projects that we contribute to. And to learn more about this, you can go to opensource.google.com.
Amazing, thank you so much. Those are some intriguing numbers, Anagha. So to add a little bit personal touch to this, let me take you back to my days where I worked with a customer who was using Teradata and mainframes. So I would go in, and then if I have to execute a query in production environment, I remember having this huge process that I go fill in, right? Say which query I need to run, what time I need to run, and you cannot run them in the business hours, right? You're talking about how we were limited in this limited data world. So if you've heard Bruno talk on the keynote from Google Cloud, he talks about limitless data. So that is what OSS has enabled us to do today. So I think OSS is definitely revolutionary, and I can see how Google, and open source share such a special relationship. So thank you for covering that, Anagha. Now that we have done that, let's talk a little bit about Google Cloud.
Sure. Actually, I'd like to start with this slide, which talks about all the Google papers over time, and it's not the entirety, just a subset. And if you see here at the center row has all the papers published over the past 2 decades. And the open source icons on top are technologies inspired by Google, some of which are contributed by Google. And at the very bottom, you'll see Google Cloud products. And some of those are actually built on technologies used across all the Google logos that you're familiar with. And they're battle tested, robust, and offered to you as a product, but not everything is open out here. So Mansi,
yes,
maybe I'll get into our cloud portfolio.
Yes, absolutely.
And what I want to highlight here is, even though this is about our analytics ecosystem that has an open source angle, what you see here is across infrastructure, applications, data, analytics, AI, ML, operations, we've got a number of products that are built on top of open source technologies. Some of these are technologies born at Google, contributed to open source. There are some that were born in open source that we productized, like for example, Cloud Composer, which is Apache Airflow as a service. So for the rest of the session, we're going to focus on products that either were born at Google, are used internally and were productized, or we've adopted from open source and productized, and that's pretty much what's going to be the focus today.
Okay, that's great. So let me give you the impact of open source, right? So you saw there's a snowball effect, like when you have one open source tool, you build, you innovate around that, you come up with new tools, you can also add a lot of value additions when you get the new tools in. Right? So as we do that, today I am thankful for my job because I think it's OSS that has made it possible. How many of you would agree with me?
How many of you use open source at work? Wow.
Look at that. So that's great. So that being said, what else does Google Cloud provide? Like any value additions when we are giving this open source services?
Absolutely. Back in 2013, I got into the world of the Hadoop ecosystem, and I had to learn to set up all these technologies, the whole ecosystem, technologies across multiple clouds from scratch, and went through the pains of installing it. And what we offer is some of these same technologies and newer ones, essentially completely productized, completely taking away most of the management challenges, the installation, the securing, the upgrades, the patching, configuring high availability, disaster recovery, etc. We take care of all of that, and scaling as well. And effectively what it does is it simplifies your adoption, allows you to focus on innovation, and accelerates speed to market.
That's amazing. Thanks, Anagha. So let's shift a gear a little bit, right? So if I take you back to time in 90s, the next big thing that got open sourced after Linux operating systems were the databases, right? You had your Postgres and MySQL emerged during the same time, and MySQL was an integral part of the LAMP stack, which actually powered all the web development. And today, databases are like key integral part of every system that we build. So Anagha, would you tell us a little bit more about our strategy and how we are thinking about open databases?
Sure, I'll do that. Before I do that, can I get a show of hands for any of you who use open source databases? MySQL, specifically Postgres, Awesome. How many of you use NoSQL databases? Fabulous. HBase? Cassandra? Any Accumulo? Okay, wonderful. What about HTAP databases? Hybrid transactional and analytical databases. Wonderful. Okay, let's look at the Google Cloud portfolio. This is not the complete portfolio of databases. There's others too. But what we have highlighted are the popular databases that have an open source angle. So I mentioned 3 categories, and the first one is relational. And for relational, we have Cloud SQL, which is completely managed MySQL and Postgres as 2 optional flavors for you, a managed solution. And essentially, you can set up a MySQL or a Postgres instance, configure it highly available. You can set up read replicas. You can have read replicas in different regions to serve as primary in the event of a disaster recovery, disaster scenario. And the scalability limit of Cloud SQL is 64 terabytes. And once you hit that and you need a more scalable cloud native database, the database that we have to offer is Cloud Spanner. This is a closed technology, but it has a PostgreSQL angle, which is generally available as of last week. So it's got full Postgres compatibility. And Cloud Spanner is our geo-distributable relational database as a service, offering strong consistency, 5 nines of availabilities, multi-master with last write wins for conflict resolution. It's a fantastic service that's used at scale, and I know some of your customers use it as well in production.
Very much, and they run like billions of transactions on Spanner today.
Right, and just to give you an idea, every second we get 2 billion requests processed through Cloud Spanner. So that's our relational tier. We've had a lot of customers ask us for a hybrid transactional and analytical database that is open source because they want to have a multi-cloud footprint, they don't want vendor lock-in, etc. So we recently announced a new kid on the block, AlloyDB. AlloyDB is managed Postgres, and it's a hybrid transactional and analytical database. And what it offers is 4x performance improvements over Postgres on IaaS from a transactional perspective, and 100x from an analytical perspective. It's a product that's built with much intelligence underneath and a hierarchical caching paradigm offering very fast performance. That's AlloyDB for you. You can learn more about it. It's in preview. You can talk to your cloud customer engineer or your sales team and basically get enlisted in a preview. The next database I'd like to talk about is our NoSQL database, Bigtable. We have multiple NoSQL offerings. Bigtable is a technology that's used internally within Google. We wrote up a paper. You guys must have seen it on the slide previously. It is a wide column or a column-oriented NoSQL database, and when it's well-tuned, can give you as much as single-digit millisecond reads and writes. It offers strong consistency, but also offers replicated clusters with eventual consistency, and you can spin up Bigtable across 8 regions simultaneously and have the replication managed by Google. And within each region, we have 3 zones, so you can have as many as 24 Bigtable clusters running at the same time. It's a fantastic service, and at peak, it serves 5 billion requests per second. And the open source angle to Cloud Bigtable, as you can see here, it's got HBase compatibility. And multi-model is the trend with cloud databases these days, NoSQL databases. So what we have customers doing is actually bolt on Janus Graph for graph databases and use Bigtable as a scalable backend. Similarly, OpenTSDB and GeoMesa on our Kubernetes engine.
Amazing.
That's what I had to share. And in terms of like a compelling story, think of Twitter processing billions of tweets per hour, and an architecture where tweets are coming in, they hit our cloud PubSub, our massively scalable PubSub messaging system, get processed through a service called Cloud Dataflow, which is our distributed processing framework, and syncing to Bigtable for fast insights.
That is amazing. Thanks, Anagha. And I would like to share one of the stories that happened to me. So you all are aware of Hive Metastore, right? If you have ever used Hadoop platform.
Right.
So I go into a customer and then they are in the situation, in a brain split situation. Have you ever heard about that? So it could happen in databases where if your data is going out of sync, you tend to lose data and there is no way for you to roll back. So having options of taking and managing those kind of scenarios are actually a lot of value addition. They take away that operational and administrative and then all that overhead away. So think about the value that you're getting in. I mean, how we are, based on an open source tool, we innovate, we can build, and we take it to a much higher level, which is nothing but the future, right?
Absolutely.
That's why future is definitely open.
Right.
Awesome. Now, that being said, let me move on to the next question. And this is one of my favorite topics, right? It's on data and analytics products. So Anagha, would you care to share with us some of the top data analytics products that you have seen in use by your customers?
Absolutely. So actually, before I get into these products, you mentioned Hive Metastore. I was not planning to cover it in this session, but I want to quickly share with you. So if you're using Spark, Flink, Presto, Drill, a variety of these technologies, you have data sitting in object storage, you apply a schema to it, you register the schema definition into a Hive Metastore once, and you basically query many times using that schema definition. And today we have a service called Dataproc Metastore, which is a highly available Apache Hive Metastore, which is built on top of Cloud SQL. That's just one thing I'd missed. Let me talk about the top data analytics services. We have a number of them with an open source angle, but these are the top 3 that I tend to work on with the customers I work with. The first one is Cloud Dataproc. So we're both former Hadoop engineers, so this product inspires me, excites me very much. Think of Cloud Dataproc as a Hadoop distribution offered by Google Cloud. We have 3 different compute options. We have compute engine based, we have Kubernetes based, and we have a serverless offering that's net new and generally available. All 3 options are generally available, and in terms of startup time, the compute engine and the Kubernetes engine have a startup time of 90 seconds regardless of the size of a cluster, and serverless, it's 45 seconds. For me, I come from a different cloud where the same setup would take 45 minutes. So when I first spun up a large cluster, it was a jaw scraping the ground moment for me because I was just amazed by the engineering excellence at Google. Let me share with you some other features. All of these 3 flavors of compute actually offer auto scaling. There's different ways through which you can auto scale, but the one flavor, which is serverless, is auto scaling by default, and all 3 of them provision compute within your network and within your project. So there's no, it's not managed by Google. You get to own the resources and they're deployed within your infrastructure. And a close complement for this is a persistent history server, especially if you're a Spark developer. These compute infrastructures can be spun up, they can be long running, they can be ephemeral. So if you're a data engineer and you're developing a whole bunch of jobs, you want to go back in time, it gets a little clunky if you have to go to a logging tool and use that for troubleshooting, especially for jobs that have completed previously. So we offer a persistent history server as part of Cloud Dataproc. You can spin that up, and when you submit a job, you can actually provide both the Dataproc Metastore as well as the persistent history server, and you can go back in time and look at your job execution in the familiar Spark UI. Beyond this, I'd like to actually double click on serverless Spark because it's new and it's seeing massive traction amongst our customers. So the entire infrastructure is spun up in your infrastructure, and pretty much what it does is it abstracts out the whole cluster concept. All you have to do is think from a job perspective. Think of what your Spark parameters are going to be, translate to the data compute unit, which is our compute abstraction equivalent of serverless Spark, and submit a job. The infrastructure is spun up in 45 seconds. You're not charged for it. Your job executes, it completes, the infrastructure is toned down, you're not charged for it. The whole thing auto scales as well. If you're new to Spark, much of it is figuring out the exact amount of resources to provide your job. With serverless Spark, it makes things a little easy for you with the auto scaling that's built in. That said, we have very large, very Spark savvy ninjas across many digital native giants that use our serverless Spark infrastructure that actually have significant expertise with Spark, and they can actually take this infrastructure and tune it further and really have amazing results with it. You can bring your own Docker images, check them into Google Container Registry, and use those to bootstrap your serverless Spark infrastructure. The whole thing is extremely secure and vastly simplifies developer productivity. And for those of you who have worked with Spark on Yarn and have run into resource issues, waited on your Hadoop administrator to grant you, enough resources, that whole problem is gone, because when you spin up a serverless Spark, when you submit a serverless Spark batch job, you're getting your own private infrastructure. There's absolutely no resource contention there. The other flavor of Dataproc is interactive sessions. There's a lot of traction and tremendous interest for using Jupyter notebooks with a Spark context. So we recently introduced, and it's in preview, serverless Spark interactive sessions. With this, you can open up a notebook server on our Vertex AI, which is our machine learning platform, and you can create something called an interactive session, which is abstracted out serverless Spark infrastructure, and start authoring Spark code, whether it's data engineering, whether it's machine learning, model training, or scoring. And you can build pipelines of this too with Vertex AI pipelines. That said, I think I've probably exhausted most of the time allocated for this session.
Sure, we'll do a quick time check, but it'll be great if you can move on to the next.
Yeah, sure.
We'll talk a little bit about Beam.
Sure. Just some quick scale facts. So about 250,000 clusters are spun up each day of Dataproc, and they're majorly Spark. 88 million Spark jobs are submitted each month. Our longest running job is several months, so you can imagine, and the reliability of the service. And then our largest cluster is tens of thousands of nodes, and again, it's Twitter. So the next service I'm going to talk about is Cloud Data Flow, and it's essentially managed Apache Beam, so it's fully open source. And for those of you who are new to Beam, it is essentially a distributed data processing framework with a unified API, just like Spark, for batch as well as streaming. It is a technology we use internally massively, and it's very robust. It's battle tested, and we offer it as a service. And from an infrastructure perspective, it's entirely serverless, and it's a no-ops platform. And there's a lot of optimizations built into the service. There's I/O optimizations. There's intelligent analysis of hot spotting while processing data, and automated data dynamic rebalancing across compute nodes. And there's DAG optimizations also that are taken care of for you. The infrastructure is self-healing. It's auto-tuning. And if you're net new to Beam and need to get started, what are some of the things that make it easy? Let's say, actually you write Beam code in Java, in Python, and Go. But if you're getting into Beam for the first time and want to use Dataflow, you can actually open up the Dataflow user interface and start writing SQL. You can write SQL against a Kafka topic or a pub subtopic, or static storage in static files in cloud storage, or it could be tables. Merge all that data, sync it to a storage system. That's one thing that makes a job easy when it comes to authoring Beam jobs. The other one is we have a number of templates readily available that you could actually enhance and build your production pipelines. We have notebooks, we have change data capture for Cloud Spanner and Bigtable that I mentioned. And beyond that, a feature that's really exciting for me is that we have a tier called Dataflow Prime. With Dataflow Prime, while we're used to seeing horizontally auto-scaling infrastructure with Dataflow Prime. We have vertical auto-scaling managed as well. And what's even better is an industry-first technology called right fitting, where we analyze a graph of a job and actually identify tasks and provide it the right amount of resources. The net benefit of this, vertical auto-scaling, horizontal auto-scaling, and right fitting all packaged in when you submit a job, is that your job gets the right resources at a low cost because it's provisioning the right amount of resources. It's reliable, tasks don't die and don't need to be started up again. And another thing is things complete faster and at a low cost. I think I'll stop there. Again, a scale story, Twitter, I mentioned, billions of events per hour.
Amazing. Thanks, Anagha. So as we have all this amazing distributed data processing system at scale, definitely, at least from the customers I have worked with, triggered thousands and thousands, probably hundreds or Ks of jobs every day. Right? What is some of our investments in that space to automate orchestration?
Right. For orchestration, we have a number of different, just like with our other hyperscaler competitors. But the open source service we have is Apache Airflow as a service. It's called Cloud Composer, and it runs on Kubernetes. And of course, we have auto scaling built in. There's cluster auto scaling node. There's horizontal pod scaling, etc., all built in. It's highly secure, and we even have customers in healthcare, financial sector, governments, etc., using this service at scale. And a recent customer story that you'll see going live on our cloud blog is with Deutsche Bank, that actually had a number of disparate schedulers, and they consolidated to using Cloud Composer very successfully, and you should soon see the story go live.
Amazing. Thank you so much. So I came into the conference today and I just passed by every person and every data person, and then when we talk, I think none of my conversation about data ended without mentioning data governance and management. Even our data story would be incomplete without talking about governance management investments. What is the latest and greatest in that field for us, Anagha?
Sure. So last year at Cloud Next, we announced a new product called Dataplex. It's a data fabric as a service. And very recently, I forget which conference, we announced Big Lake. So these two are the new kids on the block that fit into the governance story. And both of them have an open source angle. So let me get into Dataplex. So Dataplex, Intelligent Fabric. Back in the day when I used to do data engineering, I had to organize all my data in my Hadoop data lake. I had to have my lake, my zones, and the whole data lifecycle, the different areas you organize it. So I had my staging, my raw, curated consumption distribution, different optimizations, different formats to give the best performance. You take all of that and it comes as a product. The whole concept of lakes, zones, registering assets into the zones, that's one feature at a very foundation level that's available within Dataplex. Beyond that, okay, you've got your data in there. What if, as a data engineer, if schema inference happened automatically and you got a baseline schema given to you and registered in a metastore? That's another thing available in Dataplex. It will crawl, discover, infer, and register schemas both in BigQuery into the metastore in BigQuery, so that you can author BigQuery SQL against external tables, as well as you can do the same thing. The registration is done in Dataproc metastore service. So if you're using Spark, Flink, etc., you could automatically start writing code with the schema registered already and evolve it, tune it, etc., correct it as needed. There's automated cataloging as well. There's data quality and data profiling available in this product. There's the ability to actually ingest data in batch, in streaming mode, to transform data using Dataflow, Dataproc, and Data Fusion, which is CDAP, which is another open source product we have. All of this within Dataplex and orchestrated using the native scheduler or using Cloud Composer and persisted into your lakes, zones, etc. Beyond that, another capability that excites me is that you can actually explore data with Spark SQL. There's a Spark SQL workbench, and there's also interactive notebooks where you can author Spark code against data registered into your lakes and zones. And you don't have to recreate tables. You can just directly start querying it, because the notebooks, the environments, the Spark environments are integrated with the Dataproc Apache Hive Metastore automatically. Mansi, you've been working very closely with the product team on authoring data mesh strategy, data mesh architecture, etc. I think it makes sense to talk about that. There's been so many talks at the AI Summit, Data and AI Summit, about data mesh.
Oh my God, I was waiting for that for so long. I'm so excited to speak about that. So I'm a very huge evangelist both for Dataplex and data mesh, and this is primarily because of my predilections for data governance. I'm very vested in that field, and I can see the immense value both of them can bring to an enterprise, right? So Dataplex is going to be a key transformational technology that can help your enterprises or your customers as they embark on this journey of building data meshes or building data as a product. Finally, end goal of data mesh is to build data as a product, right? Now, how? So I think thanks Anagha for covering the fundamental features. So Dataplex's fundamental features and capabilities actually provide this ideal technology foundation that you can build your data mesh topologies on. So let me give you a few examples. Dataplex offers you this capability of using logical organization, right? So your data is distributed. We know that distributed data is today and in future the reality. Right? Your data will be in multiple clouds, your data will be across multiple systems. So when you put this logical organization, you build them into lakes and zones, what you can do is you will have the capability of you can always use that to manage your centralized monolithic data lakes and data warehouse. Plus, you will be able to expand the same logic, say that I have a lake. So I can build a lake which is a business-specific data domain. So I'll be able to expand that. Now, what will happen if I will be able to expand that, right? So as I start creating this decentralized, I can apply decentralized ownership. One of the example is, we know how painful when you take the data away from the actual source teams, right? Who know the data best. How do we solve a problem like that? So imagine when I create this decentralized domain through my Dataplex lakes, I can give them, the source team, the ability to come and own their data, to secure their data without having to learn anything about, say, for example, GCS security, Big Lake security, or like BigQuery security. They're just focusing on learning about Dataplex. So giving that ability using this logical organization. I'll give you another example, right? So when you have zones, right? Imagine creating a data product zone where your data product is getting built every day, it's getting refreshed every day. So you have this constant need of spinning up data management and governance tasks along with it, right? You have to go and build a data quality check. You want a timeliness score for data that gets loaded daily, right? So you have to—
Security, Mansi.
Yes, I'll get to that in a second. So as you start building that data products up, so Dataplex will be able to automatically orchestrate and run those data management tasks for you, and without the need of having the domain teams having the technical knowledge of doing that. Right? And Dataplex is empowered by whatever technologies Anagha covered, like it integrates with Spark Serverless, it integrates with Beam, it integrates with CDAP. So as a user, as a business domain owner, I don't have to go and learn each of these technologies. So Dataplex is going to give you this one-click configuration-driven way to build templates. Third, great, thanks for reminding that, right? So I think you would have heard Zamak mention yesterday, there is two components to data mesh. You have a centralized component, you have a decentralized component. So decentralized component is good. As you have seen, like you can break it up and then you can give ownership. Now, talking about centralized components, right? Think about security. Security is a centralized operation. Or think about operations such as defining your schemas, or your business tags that you want to build, or the data quality tasks that you want to build. Now, you don't want each domain teams to go and reinvent the wheel, build their own ways to do that. So what you can practically do is you can give them utilities and templates and enable them technically through Dataplex, right? So that is the power Dataplex brings in. We have like a lot of our customers like Deutsche Bank, Snap, Addio already working with us as they have like started adopting a data mesh strategy in their organization. So that being said, I think we're almost getting into the session. So let's move on to the next topic, Anagha. So if you can talk to me a little bit about like our strategic partnership with Databricks, sure. And if you can just highlight a little bit on like what use cases and the work, the trends, workload trends that you have seen at your customers.
Absolutely. I'll just give a quick spiel about Big Lake though. So Big Lake is a high performance storage engine. You take external tables and if you query external tables via Spark, via BigQuery, for example, you don't get granular like row and column level security. What we did is we recently announced Big Lake, which again fits into the data governance story. And what it is a unified storage engine for lakes as well as warehouses, for governance, for centralized governance across clouds, and supporting open formats like Avro, Parquet, Avro, Parquet, and Orc. And in the future, also with the promise of support for all the 3 popular table formats as well. Did I miss anything, Mansi?
That's cool. Okay. You got it all.
Cool. All right, speaking about Databricks. So I worked on Databricks for 3 years when I was at Azure. Very passionate, very fond of the product. It's amazing. And last year we went GA with Databricks on GCP, and the differentiator is that it runs on Kubernetes. And there's some benchmarks published by Databricks on their blog post where when it comes to scale with a large number of clusters, it's faster on GCP. We're seeing a lot of traction with Databricks on Google Cloud because many of our customers are actually adopting a multi-cloud footprint. And we have some that are migrating off of Hadoop data lakes, etc. And so we're seeing a lot of traction with Databricks on GCP. And across industries, although last year it was primarily media, entertainment, gaming, this year financial sector, we are seeing an uptick as well. And some compelling stories are, we recently had a major retailer use it for, from a streaming perspective, all the way from when a customer goes and orders something to it making it to the customer's doorstep. That entire flow from a streaming perspective and from a lakehouse perspective, all of that runs on Databricks. We have another customer that did something similar from a logistics perspective, and it's a transportation company. There's a number of publicly shareable customer success stories at our website. Once again, fantastic product, seeing a lot of traction.
We're almost getting to the end.
Yeah.
So thank you. That's a wrap. I think we'll just, do we have a couple of minutes for the Q&A?
We run out of time, so stay back. You can ask the audience questions.
Okay, stay back here. Okay, so I'm so sorry we're out of time and we have to give up the room for another talk, but we are available outside if you have any questions. Thank you so much for this opportunity.
Thank you. Have a good rest of the afternoon.